So this is chapter 3, section 11, related rates, number 71. And so for this, I've drawn a picture. Let's kind of read this. A jet flies horizontally 500 feet directly above a spectator in an air show. So here's the jet right above the spectator. And first of all, I'd like to say I know my jets and my drawings are incredibly good. And you might feel discouraged because yours aren't as good as my drawings. But rest assured, practice and you may one day draw as well as I drew. Just hang in there. So here's the plane, and then it flies, and 2 seconds later, it's over here. So I've drawn that. Here's where you might mess up. 500 feet, that's 500 feet. But the plane travels 450 miles per hour. So the 450 miles per hour, you got to ask yourself, what's changing? Something's changing as time changes. And so you have to decide. I called it P for plane, and P was the distance the plane traveled from the spectator to where it is. I call it P. You could call it X. You could call it W for wings, whatever you want. Something needs to be changing. So I chose to call it P. P is changing. And P is changing as time changes 450 miles per hour. But here is the problem. This is given in feet. If that's feet and that's miles, things aren't going to work out right. And so that's the first problem. The second problem, this is 2 seconds and this is hours. So in order to make my life better, I need units to be the same. So I decided to change the 450 miles per hour into feet per second. So the first step, I'll do down here. It's like chemistry, stoichiometry, getting your units to work out. I don't know why I put that line there. Not sure why. I don't want miles, I want feet. So on top, I say I want feet, and I want miles to cancel out. So miles on the bottom, we'll get the miles to cancel and up with feet. And the conversion is 5,280 feet is 1 mile. Next, on the bottom, I don't want hours, I want seconds. So I need to get seconds on the bottom. So here I want seconds on the bottom, and I want hours to cancel out. So I put hours on top so that they cancel. And what's the conversion? 1 hour is 3,600 seconds. So if you apply all of that, this will get you 660 feet per second. And so that's the conversion, and that's what I have written right here. So in the units I like, I get 660. Once you do that, then this problem flows a lot better. Still not perfect, but better. All right, what else is going on? It's asking determine how quickly the angle of elevation is changing 2 seconds later. The angle of elevation, they define how quickly the angle of elevation is changing. So the angle of elevation is from ground level up to the plane. That's the angle of elevation. They want to know how fast theta is changing. So they want d theta dt when t is 2. I guess we could do that, when t is 2. And that's a question mark. So now you can see our two functions that are dealing with is p, the distance the plane has traveled, and theta, that's going to be the angle that the guy's looking, or the girl. And both of those change as time changes. As time goes on, the jet travels farther and farther, so p increases. And as the plane gets farther over here, that angle is going to shrink. So they're both functions of time. So we need an equation involving theta and p, and hopefully you can see if you choose this 500, you have tangent. Tangent is opposite over adjacent. So there is our formula. Tangent theta is the opposite side over the adjacent. And we notice that theta and p are both functions. Our variable is t. These are not variables, those are functions. So we take the derivative, we treat them as functions, and use chain rule with them. All right. This is still going to get kind of ugly. What's the tangent of theta? The derivative of tangent of box is going to be secant squared of box times the derivative of box using chain rule. And on the right side, 500 is a constant. I'm going to rewrite this as p to the negative 1 power because we can take the derivative of that. So what's the derivative of box to the negative 1 power? It's negative 1 box, you subtract 1 from the power, times the derivative of box. Let's keep going. Secant squared. Secant squared is 1 over cosine squared. And we want this when t is 2 seconds. Negative p squared is the same thing as moving p squared to the bottom. And we want this when t is 2. So we're getting close. Now we know dp dt. We're going to plug this value in right here. That's pretty easy. 660. Okay, here's the problem. We need to know what p is, and we need to know what cosine theta is, and we will be like really close to get our answer. Well, how do we figure that out? What's p when t is 2? Well, how fast is this plane traveling? This plane is traveling 660 feet per second. So 2 seconds later, how far is it going to travel? That distance would be 660 times 2. That's 1320, I believe. So that distance when t is 2, p is 1,320 feet. So now we have p. Hopefully I got that right. I think I got that right. So p will be 1,320 feet. And then we still have the cosine to deal with. So I'm stuck on figuring out the cosine. What's cosine of this angle? Well, look at this triangle. We know cosine is adjacent over hypotenuse. Can I figure out the hypotenuse? Yeah, using Pythagorean theorem. So using Pythagorean theorem, the hypotenuse is 1320 squared plus 500 squared square root. And so the cosine will be 1320 over that. Woo, a lot of work. 1320 over square root 1320 squared plus 500 squared. But that whole thing is squared because cosine is squared, so I have to square the whole thing. Wow, I'm running out of room. Okay, I am dividing a number by a fraction. I'm going to multiply by the reciprocal. So the top will be 1320 plus 500 squared, and the bottom will be 1320 squared. Why? Because these are being squared. So when I square the square root, they cancel. And multiplying by the reciprocal, I get that. Ooh. I'm going to ignore the units right now because I have enough to deal with. Now, to get rid of this, I multiply both sides by the reciprocal of that. 1320 squared over 1320 plus 500. I multiply both sides by that. Whew. All those cancel. And we get a final answer. Oh, those cancel too? I'm going to pop that in my calculator. I hope it comes out right. My hopes are not that high. I'm not very confident because there's so many places where I could have made a mistake. Let's see if this works. Okay, I have an answer. And I don't think it's right. Well, maybe it's right. I'm getting 0.166. Oh yeah, it's supposed to be negative. I just realized that. I'm so smart. Because that negative right here needs to be brought down. I am so smart, aren't I?